Tonight's lesson is on adding signed rational numbers. Our objective is I can add signed fractions and mixed numbers using number lines and the rules for addition of integers. Now you know how to add fractions. If they have a common denominator, you add the numerators, you keep the denominator. If they don't have a common denominator, you find a common denominator, rewrite your fractions using that common denominator, and then add your numerators, keep the denominator. The only difference today is going to be that our fractions will have positive and negative signs. So we're going to have to follow our rules for adding integers to help us tonight. Let's find the following sum on a number line model. Well, this number line is broken into halves, 0 to 1/2, over to 2 halves. 2 halves is the same as 1. 3 halves, 4 halves is 2, and then going the opposite direction, -1/2, -2 halves, which would be -1, -3 halves, which is -1.5, -4 halves, which is -2. I know last year you located negative and positive rational numbers on a number line. Now we're actually going to try combining them, adding them up. So -3 halves, again, we start at 0, we move 3 halves to the left. If you're adding a negative on a number line, you have to move left. So from -3 halves, we're going to move an additional 1/2 to the left. And where do we end up? We end up at -4 halves, which is 4 divided by 2 is 2, -2. And there you have it on the number line. Let's look at the same example without using a number line. Circle the sign that goes with the number. That's our step 1 when we were adding integers. It's the same if we're going to add signed fractions. So that first number is a negative. The second number we're dealing with is also a negative. Are the signs the same or the signs different? Those signs are the same. If those signs are the same, we're going to go ahead and find the sum. What's the sum of 3 halves and 1/2? 3 halves plus 1/2. Common denominator, you remember we keep that denominator. And then you just add your numerators. 3 halves and 1/2 is 4 halves. And we even drew pictures for ourselves when we first started reminding ourselves of fractions. There's 3 halves. That's an ugly half. We're going to add on another half. How many halves do we now have? 1, 2, 3, 4 halves. We were using visuals earlier this school year. And what's 4 divided by 2? Oh, that's 2. 4 halves is 2 whole. If I shove those halves together, I have 1, 2 whole circles. Okay. So are the signs were the same, so we found the sum. Since we have a common denominator, we add the numerators, we keep the denominator, and that's just a visual for that. The next thing you want to say to yourself is, what do I have more of? Well, even if I just focus on the numerators, here I have 3 negatives. Here I have 1 more negative. How many do I have running around? Oh, I have 4 negatives running around. There are no positives. My answer must be negative. Same exact rule that we used when we were adding integers. And -4 halves is a -2. We only had negatives. Our answer was negative for that one. This is a visual of -1/4 plus 3/4 on the number line. So if we start at -1/4, you went from 0 to -1/4. Again, this number line is broken into fourths because we're adding fractions that involve fourths. So we have 1/4, 2/4, 3/4, 4/4 is 1, -1/4, -2/4, -3/4, -4/4 is -1. If we start at -1/4, now we're adding a positive. To add a positive, what direction do we move? You remember, to add a positive, we move to the right. So we're going to move to the right how far? 3/4. This is broken into fourths, so from -1/4, we're going to move to the right 1, 2, 3/4, and we end up here at 2/4. 2/4 is the same as 1/2 when we simplify that. So that would be using a number line. And again, if you want to use number lines to help you add fractions, you're going to want to make sure you break your number line up into whatever the denominator tells you you're working with. In this case, it was fourths. Now let's use that same example, but using our rules for adding signed numbers. You have negative 1/4 plus 3/4. We know that that's going to end up with 2/4. Let's check this with our rules. First step is circle the sign that goes with the number. So you're going to circle the sign that goes with each of the numbers. Now, in front of the 1/4 is a negative. In front of the 3/4, there's not really a sign unless you talk about that addition sign. If no sign appears in front, we know it's a positive. Then you look and you say, are those signs the same or are those signs different? Well, this one's negative. That's a negative sign. This sign is a positive. Those are definitely different. Those signs are different, so we find the difference. We know what that means to subtract. So if we're going to go ahead and find the difference here, we're going to take 3/4 minus 1/4. 3/4 minus 1/4, they have the same denominator. I keep my denominator. 3 minus 1 is 2/4. Then I just look and I say to myself, okay, what do I have more of? Well, I can just focus on my numerators. Here I have 1 negative fourth. Here I have 3 positive fourths. What do I have more of? I definitely have more positives. Negative with a positive, those zero out. How many positives am I left with? Positive 2. Positive 2 what? Positive 2/4. So that's how I know my answer will be positive. How do I simplify 2/4? Divide top and bottom by 2, numerator and denominator by 2, and I end up with 1/2. So that answer is a positive 2/4. I restated, you have more positives or negatives, you have more positives, so boom, your answer is positive. Let's take a look at another example together. This example is dealing with mixed numbers. In this example, again, I have common denominators, which is going to be helpful. What we're going to do is we're going to do this example on the number line. So first it says 1 1/2. So again, I broke my number line into halves. 1/2 and another half becomes 1. There's 1 1/2. There's 2, 2 1/2, 3. I broke into halves. So I'm going to go from 0 to 1 1/2. Then I'm going to move to the left. When I add a negative, I move to the left. So I'm going to move to the left 2 1/2. Well, let's see. If I move to the left a half, I end up there, and then 2 more. 1, 2 more. I'd end up here at -1. So on a number line, you can work it out that way. You can start at your 1 1/2, move left a half, 2 more wholes, you end up at -1. Let's go ahead and take a look at that example without needing a number line, just using our rules for adding signed numbers. So what's our first step always? Circle the sign that goes with the number. That first number doesn't actually have a sign in front, so we're like, oh, that means that that's positive. Then the second number has a negative right in front, that's negative. And you ask yourself, are those signs the same or are those signs different? Well, the first one's positive, the second one's negative. Those signs are different. You're going to find the difference. So we have to find the difference between 2 1/2 and 1 1/2. So we would do 2 1/2 minus 1 1/2. 1/2 minus 1/2, that's 0 halves, that's gone. 2 minus 1 is 1. The next step you'd ask yourself is, what do I have more of? Do I have more positives or do I have more negatives? Well, let's see. Here I have 1 1/2 positives. Here I have 2 1/2 negatives. What do I have more of? Oh, I definitely have more negatives. We have more negatives. So our answer needs to be negative. So our final answer here would be a -1. We found our difference, realized we needed more negatives. Our answer would be a -1. How about if we add rational numbers that don't have a common denominator? Same process. Are the signs the same or are the signs different? So if I look at this one, the signs are the same. What's the sign on that 3/4? Oh, right in front of that is a negative. What's the sign on the 9/5? Oh, right in front of that is a negative. So if the signs are the same, we're going to find the sum. That means I want to take the sum of 3/4 and 9/5. And so in order to find the sum, I need to find a common denominator. Well, what's a common denominator between 4 and 5? Oh, 20. Signs are the same. I'm going to find the sum. 5 times 4 is 20, so here we have to do 9 times 4 is 36. 4 times 5 is 20. 3 times 5 is 15. You'll remember these are just rewriting these as equivalent ratios with a denominator of 20. 15 and 36. 36 and 15 would be 5 and 6 is 11. 3 and 1 is 4 and 1 is 5. That's 51/20. Whew, we normally don't leave our final answer as an improper. How many times does 20 go into 51? Twice. That gets us to 40 with 11/20 remaining. So when we find the sum, we get 2 and 11/20. Next thing to ask yourself, do we have more negatives or more positives? So we look here. What's the only thing we have running around? Hey, we only have negatives running around. Therefore, our answer needs to be a negative 2 and 11/20. But here's all your scratch work off to the side, finding the sum of those values. In your last step, you're just deciding, oh, okay, we only have negatives. My final answer must be negative. What I'd like you to do is I'd like you to try adding the following signed rational numbers and be ready to share your results in class tomorrow. I'm not going to walk you through these. I'm going to ask that you try these on your own and bring them to class tomorrow. So you need to make sure you go back, you rewind, you rewatch the video if there's any key parts you need. But basically, you're following your rules for adding integers, except now we have fractions. Circle the sign that goes with the number. Are the signs the same or are the signs different? If the signs are the same, find the sum, keep the sign. If the signs are different, find the difference, keep what you have, quote unquote, more of. Try to have a good night. See you tomorrow.